Welcome to this video. Here we'd like to talk about some prerequisite concepts that are important to understanding how neural networks function. Today's topic is a very easy one. It is the concept of weighted sums. This might be quite simple for some of you, and if that is the case, you can feel free to skip this video. For those of you who still want to go through it, you'll see this is just a very simple adaptation of the basic sum. However, weighted sums play a very central role in the way neural networks function and in the way that quite often we try to understand how neural networks are, what you would call how the neurons are firing. So without any further delay, let's get into it. We'll talk about a weighted sum is basically we're taking a sum with some weights multiplied with the values. But let's start off with some values to begin with. And we're going to talk about 4 different values to begin with. Let's say the value V1 is 100. The value V2 is 150. Value V3 is 80. The value V4 is 170. So I have 4 different variables, V1, V2, V3, V4, and right now each of these contain the values 100, 150, 80, and 170. So if we were to take a regular sum, this would be V1 plus V2 plus V3 plus V4, which would be equals to 100 plus 150 plus 80 plus 170, which should be equals to 500. There is, of course, a shorthand for this, which is using the sigma notation, the summation notation, where we start from I equals to 1, because I have started my subscript from 1 and moving to 4. So I equals to 1 to 4, V of I. And you could unroll this by saying I equals to 1, that would be V1, and then the summation says plus, and then I will be equals to 2, V2, so on and so forth, V1 plus V2 plus V3 plus V4. So I'm iterating from 1 to 4. All right, so this summation and this summation is exactly the same thing, and this is also going to be equals to 500. All right. Now a weighted sum in this case. So let's introduce a new variable called weighted sum. A weighted sum is simply I take each of my values and multiply them with a weight. So let's say I have a weight W1 and I multiply the V1 with W1 and then add a weighted V2, and the weight for V2 is W2 plus W3 V3, W3 being the weight for the variable V3, and W4 V4, the weight for variable V4. Now, really W1, W2, W3, W4 are also variables, but here we are, our concept is that we are using them as a weight to the variables that we are interested in. So our variables are still V1, V2, V3, V4, and these are acting as weight variables. Okay. Now, of course, this is very simple, that for the case where W1 is equals to 1, W2 is equals to 1, W3 is equals to 1, and W4 is equals to 1, the weighted sum variable, weighted sum is equals to 1 multiplied by V1 plus 1 multiplied by V2 plus 1 multiplied by V3 plus 1 multiplied by V4, which is the same as saying V1 plus V2 plus V3 plus V4, which is the same as sum. So as you can see, this normal summation is just a special weighted version of the weighted sum. So for a special ascription of weights, weighted sum and sum are exactly equal. Okay. Now let's think about another very common thing that we calculate, which is the average. The average is really, in most cases, the sum divided by count. And in this case, because we had 4 variables, the count is simply 4. So in this case, it will be sum divided by 4, which is the same as writing V1 plus V2 plus V3 plus V4 divided by 4, which is of course the same as writing 1/4 V1 plus 1/4 V2 plus 1/4 V3 plus 1/4 V4. Sorry, that should be V4. Now, if I were to say that this is W1, W2, W3, and W4, then for weights W1 equals to 1/4, W2 equals to 1/4, W3 equals to 1/4, and W4 equals to 1/4. For these particular weight assignments, the average is simply a special case of the average is also a weighted summation. Right? Okay. Now we could do other things. For example, we can use weights as selectors, and I'm not using this as a technical term. I'm using this as a descriptive term. So, for example, if I were to have a variable result, and I wanted to say that result is equals to W1 V1 plus W2 V2 plus W3 V3 plus W4 V4. And now if I wanted to say, for the case where W1 is equals to 1, W2 is equals to 0, W3 is equals to 0, and W4 is equals to 0, for this case, result is simply equals to W1. So for a special assignment of weights in this equation, I can simply pick out one variable by simply assigning a special set of weights. In this case, W1 equals to 1, and the rest will be equals to 0. I could do a mixture. So I could say that for W1 equals to 0, W2 is equals to 1, W3 equals to 0, and W4 equals to 1, result would then be V2 plus V4, because this would be 0, this would be V2, this would be 0, and this would be V4. So again, using a special ascription of weights, a special set of weights, we can do either we could just simply select out one variable, or we could mix variables. And as you can probably imagine, we could mix variables at different rates. So for example, we could have tried to do that W2 is equals to half and W4 equals to 1. At that point, this would become half V2 plus V4. That should be V4, right? Okay. Now, let's think about another example, a different example for now. So, say I'm a teacher and I've got multiple assessments that I've done over a semester, So let's say I've taken the final exam. And the final exam, out of 100, someone received 80 marks. I've taken a midterm exam and someone's received 60 marks out of 100. I've taken a quiz and someone's received 70 marks out of 100. And let's also say that I've taken a deep learning project and someone has received 90 marks out of 100. Okay, so for these assessment items, someone has received these marks, and now let's give each assessment item a weightage. And let's say when I'm calculating the final semester marks, I will be taking 30% of the marks from the final. I'll be taking 25% of the marks from the midterm, 20% from quizzes, and 25% from the project. So if I add up these weights, the weights should add up to 100, meaning that my final semester mark will be out of 100, but 30% of that mark will depend on the final, 25% on the midterm, 20% on the quiz, and 25% on the project. Now, if I were to do just a naive average, then the naive average, as you can imagine, is simply going to be 1/4 of this plus 1/4 of 80 plus 1/4 of 60 plus 1/4 of 70 plus 1/4 of 90, given that I have 4 assessment items. Right? So if I were to use certain variables names here, so let's say I represent the final mark as F, the mid mark as M, the quiz mark as Q, and the project mark as P, then my average, as we've seen before, my average just of these 4 marks, not my semester average, my average of just these 4 marks would be 1/4 of F plus 1/4 of M plus 1/4 of Q plus 1/4 of P. And sure, in the last sheet we used V1, V2, V3, V4, but now our variables are simply F, M, Q, P, and these 1/4 values are the weights. Okay, now let's try to calculate my actual semester marks using the weights that I've got here. So what I need to do is I need to rescale my final mark that I received out of 100 to 30, the final mark the mid mark that I received out of 60, out of 100 to 25, and I'll need to rescale this mark, which I received out of 70 to 20, and out of 100, the mark that I received here out of 100, it now needs to be rescaled so that it becomes out of 25. So we'll just use basic arithmetic to do this, which is going to be 80 divided by 100 multiplied by 30 plus 60 divided by 100 multiplied by 25 plus 70 divided by 100 multiplied by 20 plus 90 divided by 100 multiplied by 25. Now I'll take this opportunity to get rid of these numerical values of the marks and replace them with the variables. Right, so it's going to be F, M, Q, P. Now, the way that this equation is written down now, it looks like that the weights are the variables and these are the weights. So let's just change it so that it suits our narrative, and we'll just simply now say this is going to be 30 divided by 100 multiplied by F plus 25 divided by 100 multiplied by M plus 20 divided by 100 multiplied by Q plus 25 divided by 100 multiplied by P. Now, these two are exactly the same. Because I'm doing multiplication, I can easily swap them around this exactly the same way, which is equals to 0.3F plus 0.25M plus 0.2Q plus 0.25p. In this case now, as you'd see, that the semester marks are simply a weighted summation of my variables f, n, q, and p, where these are my variables and these values are my weights, which have been predetermined through some examination policy. Okay. Now, let's just revisit average for a slightly different case. Let's revisit average. Okay. Let's define a function c. Oh, okay, we'll not make it that complicated. We'll say c of apple is equals to the cost of one apple. And for now, let's say it's equals to 60 taka. C of egg is the cost of one egg. Let's say is equals to 10 taka. And C of onion is equals to cost of one onion is equals to, let's say, 20 taka. And of course, this I actually don't have any idea what's the cost of these things in the market, but we're just going with it. Okay, so if I were to buy, so if I bought one apple, 4 eggs, and 3 onions, what is my average cost per item? What is my average cost per item? So in total I have 1 plus 4, 5 plus 3, 8 different items. Okay, so this is going to be quite easy. I can simply say my total cost, so instead of sum, let's use the term total cost. My total cost is equals to $60, which is 1 apple, plus 4 eggs, so plus 10, plus 10, plus 10, plus 10, plus 3 onions, so 20 plus 20 plus 20. So my total cost is equals to 160 taka. So that's 60 plus 10, 70, 80, 90, 100, 120, 140, 160. Okay. So my average cost is 160 divided by 8, which is equals to 20, sure, but this is equals to 60 plus 10 plus 10 plus 10 plus 10 plus 20 plus 20 plus 20 divided by 8, which is equals to 60 plus 40 plus, actually let's write it out, 60 plus 4 times 10 plus 3 times 20 divided by 8, which is equals to 1 by 8 times 60 plus 4 by 8 times 10 plus 3 by 8 times 20. Oh, running out of space. So those of you who remember the definition of an average in terms of a probability, you will see that this equation is equals to the probability of buying an apple. So in this case, my probability of buying an apple is 1 out of 8. So this is my probability of an apple multiplied by the cost of an apple plus the probability of eggs, of me buying an egg, multiplied by the cost of an egg plus the probability of me buying an onion multiplied by the cost of onions, which is the formula for expectation, which you should have seen in a statistics course. Now, what is interesting is that the formula for expectation is really simply a weighted summation of, in this case, the cost and the probabilities. But in any case, if you have a distribution, or if you have a situation where you have a non-uniform probability distribution, then the formula of this formula where you multiply the probability with the values and keep on adding is really just a weighted summation. Now, what's also very interesting is this, that if I wanted to take these costs, and let's say I've got these costs where an apple costs 60 taka, an egg costs 10 taka, an onion costs 20 taka, and let's move. So let's say 60, 10, and 20. 60 being the cost C apple, C egg, the cost of an egg, and this is the cost of an onion. And if I said that if I bought one apple, 4 eggs, and 3 onions, what's my total cost? Then the way we do it is we multiply 1 by 60, 4 with 10, 3 with 20, and then we add up the values. Right? That's what we do. If someone bought 2 apples, 1 egg, and no onions, then we would do exactly the same thing again to find their total cost, which would be multiply 2 with 60, 1 with 10, 0 with 20, and then add up all the results. As it turns out, this operation is exactly what we do in a matrix multiplication. In a matrix multiplication, what we do is we take this row and multiply each element of this row with each element of this column vector. Right? So 1 would be multiplied with 60, 4 with 10, and 3 with 20. And the same thing is going to happen here. 2 with 60, 1 with 10, and 0 with 20. Right? And in doing so, what we're doing is we can use a matrix multiplication to give me 2 weighted sums, in this case 2 different weighted sums of these values here. Right? And I hope we can have more of these conversations in a later video. Thank you.